Okay, so let's talk about radical equations. Okay, so radical equation means there is a square root sign in the equation. Okay, in the equation. So the main idea is we will change this radical equation to either linear equation or quadratic equation. Okay, yeah. So after that, we solve linear equation and quadratic equation. Then we get the solutions for the radical equation. Okay, radical equation. So let's write down the first example. Okay, let's write down the first example. So let's solve square root of x plus 5 is 3. Okay, is 3. So there is a square root in the equation, so that's why it's called the radical equation. Okay, radical equation. Okay, so now the main idea, the first idea is you want to cancel this radical sign. Okay, so how to cancel radical sign? We use the second power. Okay, we use the second power. So radical sign and the second power canceled. You got whatever inside the radical sign. Okay, radical sign. So step 1 here, we will take second power of both sides of the equation to cancel the radical sign. Okay, yeah. So square root and the square canceled on the left. Second power and radical sign canceled on the left, so we got x plus 5. And on the right hand side, 3 squared. So 3 squared is 9. So we got a new linear equation, right? So this is a linear equation. Solve this linear equation. So minus 5 on both sides. We got a solution, x is 4. Okay, we got x is 4. Okay, so for linear equation, the solution is x is 4. So this number 4 may not be the solution for our radical equation. Okay, the solution for our radical equation. So now we have to check it. Okay, this is very important. The difference between linear equation, quadratic equation, and radical equation is you have to check the solutions. Okay, so how to check the solutions? You have to plug in the number 4 back to the original radical equation, right? So the original equation is x, check it, plus 5 is 3. So now we change this x to change this x to 4. Okay, so 4 plus 5, 9. Radical 9 is 3. So it is the solution of the radical equation. Okay, yeah. So that's our first example. That's the easiest example. Okay, yeah. So a little bit harder example. So number 2, square root of 2x plus 1 minus 5 is 0. Okay, is 0. So in the beginning, you cannot use second power to cancel the radical sign, right? Because you have two terms together on the left. Okay, on the left. So now let's write down step 1. Isolate radical term. Isolate radical term. Okay, yeah. So we have to move or cancel this negative 5. Okay, move it to the right or cancel that. Okay, so let's write down step 1. Add 5 on both sides. Okay, so for negative, positive canceled. We got only the radical term on the left and number 5 on the right. So now this back to our first example, right? Only one radical on the left. So now step 2, square both sides. Okay, square left hand side, square right hand side. Okay, so square both sides to cancel the radical sign. Okay, the radical sign. So now this on the left is cancelled. Square root sign second power cancelled, so we got 2x plus 1. And on the right, 5 squared, we got 25. Okay, 25. So we got a new linear equation. Okay, new linear equation. So step 3, solve the linear equation. Solve for x. And the step 4, after you solve it, you have to check it. Check it. Okay. Check the solution. Okay. So minus 1, we got 2x is 24 divided by 2 divided by 2. We got x is 12. Okay. X is 12. So this is step 3. We got a solution number 12. So we have to check it. Okay. We have to check it. So let's check it here. So change this x, okay, go back to the original radical equation, change this to 12, okay, change this to 12. So check it. Okay, so radical 2 times 12 plus 1 minus 5. So we want to see whether this is equal to 0. Okay, so this is 24. 24 plus 1, 25. So radical 25 minus 25. So 0 is 0. So we got a solution. Okay, we got a solution. So number 12 is the solution for this linear equation and for this radical equation. Okay, for this radical equation. So this is the easier case. You change it to a linear equation. Okay, a linear equation. So let's look at one more example about linear equation, and then we go to the quadratic equation part. Square root of 3y minus 1 is, okay, yeah. So now for this example, both sides we have square root. Okay, we have square root. So again, step 1, isolate the radical terms. So if they are already isolated, you don't need step 1, right? So now step 1, isolate. It's trivial, so now step 2. Square both sides, right? Square both sides. So let's change the color. Square both sides. Okay, square both sides. Okay, so now square root and second power cancelled. So they cancelled. They cancelled. So we got a new equation. 3y minus 1 is 2y plus 5. Okay, 2y plus 5. Is another linear equation, so we just solve it. Step 3, solve for y. Solve it. Okay, solve the linear equation. So first we combine numbers. So plus 1 plus 1. We got 3y is 2y plus 6. And then we combine y terms, right? Minus 2y minus 2y. So we got y is 6. Okay, y is 6. And then step 4 is the most important step. Okay, a lot of students forgot the last step. Check it. Okay, check it. So we use the original radical equation, right? Square root left, square root on the right. So if y is 6, right? Y is 6, so we got 3 times 6 minus 1 on the left. If y is 6, we got 2 times 6 plus 5 on the right. Okay, so left hand side we got 17, right? 18 minus 1, 17. Right hand side we have 12 plus 5, 17. So it is correct. So this is the right answer. Okay, this is the right answer. So isolate, square both sides, solve it and check it. Okay, solve it and check it. Okay, so that's the linear equation case. Okay, that's the linear equation case. So now let's look at quadratic equation case. Okay, we follow exactly the same steps, but we need to solve a quadratic equation. Okay, yeah. So number 4. Square root of 2x plus 3 is x. Okay, solve this equation. Okay, solve this equation. So step 1, isolate. isolate the radical term. So we only have a single radical term on the left is isolated, right? Step 1 is trivial. And then step 2, square both sides, right? Square both sides. So this side squared, that side squared. Okay, that side squared. So what we will have, on the left, radical sign and second power, they canceled each other, right? Here, canceled. So we got 2x plus 3 on the left, and then on the right we get x squared. Okay, x squared. So you see we have a quadratic equation. Okay, quadratic equation. So we have to solve this quadratic equation. Okay, quadratic equation. So that is step 3, solve it. Okay. Solve the new equation. Okay. Solve the quadratic or linear equation. So we have to make sure one side is 0. So we move everybody to the right hand side. X squared minus 2x minus 3. Okay, minus 3. So now I will use factoring method to solve this quadratic equation. Okay, so after radicals, we will study quadratic equations. There will be 2 more new methods. Okay, you can use completing square method, you can use quadratic formula. Okay, so now let's just use factoring method. Okay, yeah. So we want to factor this side. Okay, so this is x times x because this is x squared, right? And then 3 is 1 times 3, and then it's more negative, so this is negative 3, this is positive 1. Okay, positive 1. So we change the quadratic part, the right hand side, to a product. So now we use zero product property, right? Okay, yeah. So product is 0, so that implies this is 0 or that is 0. Okay, that is 0. So we got 2 new linear equations. X minus 3 is 0, or x plus 1 is 0. So solve this, plus 3, we got x is 3. Minus 1, we got x is negative 1. Okay, negative 1. So now we got 2 solutions, x1 and x2 for this quadratic equation, right? So step 4, we have to check it. Check both, right? Check both. 3 and negative 1. Okay, 3 and negative 1. So let's check them. So first, let's check 3. So you plug in 3, right? 2 times 3 plus 3. We want to know, is it equal to 3, right? This is the x. Okay, yeah. So check x1 is 3. So this side is radical 9, so radical 9 is 3. So x1 is okay. So x1 is the solution. So now let's check x2. x2 is negative 1, so when you plug in, so you got square root of 2 times negative 1 plus 3. And on the right hand side, you got x is negative 1, right? So we want to check whether we have an equal sign, right? Equation. So 2 times negative 1, negative 2, plus 3 is 1. So this is radical 1 is negative 1. So definitely this is wrong. Okay, this is wrong. Left hand side is 1, right hand side is negative 1. They're not equal. Okay, they're not equal. So you have to delete this solution x2. Okay, x2. So the only solution is x1, number 3. Okay, number 3. So you have to drop negative 1. Okay, negative 1. So there are 2 solutions for quadratic equations, but there are only 1 solution. There's only 1 solution for the radical equation. Okay, for the radical equation. So let's look at one more example. Okay, one more example. Number 5. Square root of x minus 2 plus 2 is x. Okay, is x. So step 1, you have to isolate radical term. Okay, so there are 2 terms on the left. You cannot take second power here. Okay, you have to cancel this term and then take second power. So minus 2, we got radical x minus 2 is x minus 2. Okay, so the only term on the left is the radical sign. So step 2, second power, right? Okay, you take second power. So on the left, second power, square root, they cancelled. These two cancelled. So we got x minus 2. On the right hand side, we got x minus 2 squared. So what's x minus 2 squared? You have to use FOIL method to calculate that, right? So this is x times x squared. Okay, and then x times negative 2 minus 2x. 2 times x, negative 2x. Negative 2 times negative 2, positive 4. So this side is x squared minus 4x plus 4. Okay, plus 4. So you have to use FOIL method to find x minus 2 squared. Okay, squared. So now plus 2 minus x to make one side equal to 0, right? Make the left hand side equal to 0. So we got x squared minus 5x plus 6. Okay, plus 6. So now the next step, solve this quadratic equation, right? So we get a new quadratic equation, we have to solve it by factoring. Okay, by factoring. So 0 is x and x minus 5 minus 1. 2 and 3. So let's go back a little bit. Okay, minus 2 minus 3. Okay, minus 2 minus 3. So product is 6, sum is negative 5. Okay, sum is negative 5. Okay, so we change this quadratic to a product. So now 0 product property tell us, okay, the product is 0, so this is 0, that is 0. Okay, so we get two new linear equations. X minus 2 is 0, so x1 is 2. X minus 3 is 0, so x2 is 0. So x2 is 3. Okay, is 3. Okay, yeah, and this is not the last step. Okay, the last step, you have to check both answers. Check it. Okay, check it. So now let's check them here. So x1 is 2. So we look at the whole equation, right? So this is radical 2 minus 2 plus 2 is this equal to 2. So this is 0, so radical 0 plus 2 is 2. Checked, right? So this is x1 is okay. x2 is 3, so let's check it. So 3 minus 1 plus 2, is it equal to 3? So this is 3 minus 2, sorry. 3 minus 2, 1. So radical 1 plus 2. Radical 1 is 1, so 1 plus 2 is 3. Okay, is 3. So they both checked. Okay, so we have two solutions. x1 is 2 and x2 is 3. Okay, so the previous example, we have to draw up a solution. Okay, so let's go back a little bit. You see here, after you check it, this one doesn't work. Okay, you have to drop a solution, so there's only one solution for the radical equation. But this example, after we check it, we have two solutions. They're both okay, so we have two solutions for this radical equation. Okay, radical equation. So now let's look at some harder examples on the web work. Okay, so let's look at this hard question in the web work. Okay, in the web work. So both sides we have radicals. Okay, both sides we have radicals. We cannot isolate both of them. Okay, yeah. So this is the harder case. Harder example in the web work. Okay, yeah. So first we square both sides to cancel the radical sign on the left. Okay, we cancel this radical sign on the left by taking this second power. Okay, second power. So we got 7x plus 1 is equal to, so the square of the right hand side, you have to use FOIL method again. Okay, so 1 plus this radical times 1 plus this radical. FOIL method. 1 times 1, we got 1. 1 times this radical, so we got 7x minus 1. 1 times that, so inner product 7x minus 1, and then radical times radical, so we got radical canceled there, so it's 7x minus 1. Okay, 7x minus 1. So let's rewrite combine the two radicals on the right hand side. Okay, so now we can combine these two terms, right? So 7x plus 1 is 7x plus 2 radical 7x minus 1. Okay, minus 1. So now on both left and right we have 7x, right? So cancel them. Minus 7x minus 7x. Then we got 1 is 2 7x minus 1. Okay, minus 1. So now we can divide by 2 here, right? Divide by 2 to isolate the radical term, right? Divide by 2 to isolate the second radical term. Okay, yeah. So we got 1/2 is radical 7x minus 1. Okay, so now we can take second power again to cancel the second radical sign. We have two radical signs in the beginning, right? When you take second power in the beginning, you only cancel the one on the left, right? Yeah. So second power, we got a new equation. So this is 1/4 is 7x minus 1. Okay, yeah. So now add 1, solve this linear equation. So we got 5/4 is 7x divided by 7. We got 5/28 is x. Okay, is x. So this is a very hard question. Okay, very hard question. So I'm going to skip the checking part. So check it. It is a solution. Okay, it is a solution. Okay, so for very hard question, you have to take second power again until you canceled all radical signs in the equation. Okay, in the equation. Okay, so for most students, you only need to understand the basic case. Okay, the basic case. But we practice all questions on the web work. This is the last 3 questions. You may meet this case. Okay, you may meet this case. And there's also a cube root equation in the web work, right? Cube root equation. So this is like cube root of 3x minus 1 is 2. Okay, is 2. So if this is a cube root, you cannot use second power to cancel cube root, right? So you have to use third power to cancel cube root. Okay, so cube root and third power, they cancel each other. Then we got 3x minus 1 is 8. So plus 1 plus 1. 3x is 9 divided by 3 divided by 3. X is 3. Okay, x is 3. And then when you go back, check it, it is the solution. Okay, it is the solution. Okay, so let me repeat how to check it. You plug in this number 3 back to the original equation, right? Original equation. So the original equation is cube root of 3x minus 1. So we want to check whether this is 2 if you delete the x and put number 3, replace x by 3 here. Okay, by 3 here. So it was 3x, so now it's 3 times 3, right? So cube root of 9 minus 1. So cube root of 8, which is 2. So it is the solution. Okay, it is the solution. So when you check a solution, always use the beginning given equation. Okay, given equation. So this is the radical equation part. Okay, radical equation part. So the idea is we use second power to cancel radical sign. Change it to linear equation or quadratic equation. So solve it and then check the solutions. Okay, check the solutions.